Hello and welcome. In this video I'm gonna show you how we can use implicit differentiation for finding equation of tangent line. Find the equation of tangent line to the curve at the given point. The curve is x to the 2 plus y to the 2 equals 2x to the 2 plus 2y to the 2 minus x all to the power of 2. And the point of tangency that we want to find the equation of tangent line at that point is given 0 and 1 over 2. We know that for finding equation of tangent line, we need the slope and the point of tangency. We have the point. The only thing that we have to find is the slope of tangent line. But we know that the slope of the tangent line is derivative of the function dy over dx or y prime. So we use implicit differentiation method for finding derivative of this. If you remember, for finding derivative with implicit differentiation method, we take derivative of the both sides of the equation with respect to x. Attention, we want to find dy over dx. And because in the denominator of this notation we have x, we take derivative of both sides of the equation with respect to x. What is derivative of x to the 2? Derivative of x to the 2 is 2x. What is derivative of y to the 2? 2y y prime. Remember, when we take derivative of y, a term involving y, always we have to multiply the derivative by y prime because we use chain rule. So derivative of y to the 2 is like x to the 2. Derivative of x to the 2 is 2x. Derivative of y to the 2 is 2y. But because here y is a function, it's a function of x, so in its derivative we have to multiply by derivative of the inside. And because y is a function of x, so derivative of inside is y prime. Now let's take derivative of the right side of the equation. For finding derivative of this, we use the power rule. We bring the power in front and we subtract the power by 1, so we make this power 1. But don't forget to multiply it by derivative of the inside. So derivative of the right side is 2 times 2x to the 2 plus 2y to the 2 minus x all to the power of 1 times this by derivative of the inside, derivative of this, derivative of the inside of the bracket. Derivative of 2x to the 2 is 4x, derivative of 2y to the 2 is 4y y prime minus 1. Derivative of x is 1. And we don't need to put this power 1 on top of this bracket here. Now maybe you think to solve this equation for y prime because we want to find y prime or dy over dx. But attention, here we are not looking for y prime in general. We don't want to find dy over dx in general. We want to find only a slope of the tangent line or y prime only at this particular point. So it's not necessary to try and solve this for y prime. Directly you can use these values for x and for y here, and you can find y prime at this particular point. If you want, of course you can find y prime from this equation. You need to do lots of algebra to find y prime. So let's plug in 0 for x in this equation and 1/2 for y. Then we have this 2 times x here. 2 times x is 2 times 0 because x is 0. 2 times 0 is 0. So this would be completely 0. Let me write 0 plus 2 times y. Y is 1/2. 2 times 1/2 is 1. So this would be 1 times y prime, which is only y prime, equals to 2 times. The x is 0, so 2x to the 2 is 0. Y is 1/2. 1/2 to the power of 2 is 1/4. 1/4 times 2 is 1/2. So this would be 1/2 minus, again, x is 0, times by 4x, x is 0, so 0 plus 4 times y. Y is 1/2. 4 times 1/2 is 2. Attention, 4 times 1/2 is 4/2, and it equals 2. So we have 2y prime minus 1. In the left we have only y prime. No, attention, what is this bracket? This bracket is only 1/2. But when we multiply 1/2 by 2, these two cancel each other. 2 from denominator and 2 from numerator cancel each other. 2 times 1/2 is 1. So this is 1. All of this is 1. Only we have in the right side 2y prime. Only we have this 2y prime minus 1. And from this, if we subtract y prime from both sides and we add 1 to the both sides of the equation, simply we have this y prime equals 1. So the slope of the tangent line, at this particular point is 1. And now that we have the slope of the tangent line, simply we can write the equation of the tangent line at the given point. Let me remind you this formula for writing equation of a line in general. The slope, the m value is 1, x0 is 0, and y0 is 1/2. Everything is ready to write the equation of tangent line. Y minus 1/2 equals 1 times x minus 0. And from this, y equals x, add 1/2 to the both sides, then you have this equation for the tangent line. So this line is the tangent line to this function, not the function to this implicit relation between x and y at the given point. Before I finish this video, let me show you the graph of this and its tangent line at this point. It's not bad to see the graph of this function, this relation, not the function because it's not a function, and its tangent line. Here you can see the graph of that implicit relation. The name of this curve is cardioid. So that given relation in the question was equation of a cardioid. And this line here, this line is the tangent line at the point 0 and 1/2. As you can see, it's tangent at the point of tangency. I hope you liked this video. If you like this video, please subscribe in my channel to watch more videos. Thank you for watching.